73. All right, so we talked about exponential growth and decay on Friday. This is another form of the exponential growth. So it says a common application of exponential growth is compound interest. Compound interest is interest paid on both the initial investment, called the principal, and on previously earned interest. So this is really just a different form of the exponential growth formula that allows us, or kind of helps us a little bit, because remember that half-life one, which was decay, so it's not exactly the same thing, but life was every 3 days, and we wanted to know what was happening at 20 days, and then we had to figure out what to do with that exponent. This kind of takes care of all of that for us, and everything is based on yearly stuff, and instead of trying to figure out what we do to multiply and divide by months and whatever, it just kind of happens all within it. So the formula looks like this. The A is equal to the principal times 1 plus R over N to the N times T power. Okay. So A is your total balance at whatever time you were trying to calculate for. P is the principal or initial amount. Right. R is your rate, of course. N is the number of times compounded. And that's yearly, not total. And then T is the time in years. And where the other ones we had applied to things other than money, like trash in a trash bin and things like that, this is pretty much all for money. For either your account balance or even it could be your credit card balance that works kind of the same way, but that's not a good way. Like your account balance increasing is good. Your credit card balancing increasing, not good at all. All right, so our examples. Dave invests $300 in an account with a 5% interest rate. If he makes no other deposits or withdrawals, find his account balance after 15 years if the interest is compounded with the following frequencies. All right, so the first thing we write down is whatever T is. In this case, what is T? 15. And N is going to be what? What does semi-annual mean? 2. It's 2 times a year. So when we substitute all this in, A is equal to the principal amount, which was $300, times 1 plus the rate, which would be 0.05, divided by N, which is 2, to the N times T power. Now, my suggestion to you is just to put all this in the calculator just like it is. I mean, the 2 times 15, you could type in a 30 for that. But as far as what's in the parentheses, just make sure your parentheses are correct, and you can take care of that like that. It is possible to combine it. So to say, like, well, what is 0.05 divided by 2? 0.025. So this would be 1.025 to the 30th power. What I have in pink, you have to have written down. You do not have to write down what is in purple. Honestly, it's easier. Just type it all in the calculator and do it correctly, and you won't have to worry about anything else. So go ahead and type it in. Everybody needs to be typing it in, because I'm going to call on people, and you don't want us sitting there staring at you while you're typing it in because you didn't do anything when I told you to the first time. All right, Alex Marietta, tell me what you got. Looks like you're done. Okay, you all agree with that? $629.27. All right, and this is money, so it's $629.27. I'm not going to make you put this one in a sentence because all the sentences would be pretty much exactly the same, because we're just talking about account balances. So good enough. All right, we all good with that? Okay, got to make sure we're getting the right things out of the calculator too. All right, so go ahead and set up, or we'll just set it up together. On B, it says monthly, so that means my T is still 15. N is equal to what? 12. All right, so A is equal to 300 times 1 plus 0.05 divided by 12 to the 12 times 15 power. All right, so go ahead and get that typed in. All right, Abigail, you look pretty proud of your answer. You're sitting there smiling at it. So tell me what you got. Okay, $600. Y'all agree with that? Yes, $634.11. So did you type that in just all in one thing? Yeah. Okay. Anybody try and get the decimal in between before they did it? Okay, because if you do, if you didn't do that, then I do want you to do just right now. Just do 0.05 divided by 12. And tell me what's the issue there. Yeah, so it's a repeating decimal, right? So can you round that decimal and then just use the rounded number? No way, no how. Okay, so do not do that, because if you do that, it is possible that at some point you get the same answer, but there are a lot of times, and most of the time, where you do not get the same answer. Okay, and it is not accurate to the right decimal places, and you are wrong, wrong, wrong. You never, ever, ever, ever round or truncate until the very last step, which means that's another reason why it's safer just do it all at once. It doesn't even matter what it is. It'll just take care of itself. Okay, we good? Okay, good, thank you. All right, so if $2,500 is deposited into a savings account earning 8% annual interest, how much will be in the account at the end of 25 years if the interest is compounded with the following frequencies? All right, so here T is equal to 25. N would be equal to what? 4. Okay, I want to make sure everybody understands 4, because I got a 3 last period, and then his reasoning was pretty good, like, you know, the quarters give you 3 months at a time, yes, but that means it happens 4 times a year. So just make sure that you get that. That's what quarterly means. So A is equal to 2,500, 1 plus 0.08 divided by 4 to the 4 times 25 power. Now, again, on that one, I'd probably type that in like it is, but I'd probably maybe just use 100 as my exponent. Just might be easier if it's a number that's really obvious and I know. Let's go ahead and get those typed in. Arian, what'd you get? Okay, y'all agree with that? Yes. So this is going to give me $18,111.62. And everything that I have written in purple right now is what you have to write down. You have to write down the T and the N and then show that what you have substituted in, and then give the answer. Like, you don't have to have the intermediate steps, but like, this is what I'm typing in my calculator. Okay. Even if it's what? I'm sorry, say that again. Yes, if it's money, then you round up, yes. Because believe me, when they tax you on things and stuff, they're totally rounding up every time. So let's round up. All right, so daily, go ahead and just work this one out on your own. So if it's daily, what is in? 365. We just pretend like leap year doesn't exist. Alex Coatney, tell me what you got. 18,468. Okay, y'all agree with that? 18,468 and 60 cents.
Oh yeah, no, it's 59.
It's 59 cents. Good. Don't get to round it on the wrong places, right? So it's 59 cents. Good job. Now, just look at these two. This was the same amount of time that we had our money in the bank. The same interest rate. The difference was when it was, whether it was compounded daily or quarterly, and that's a considerable amount of difference there, right? Things you want to look into when you're looking for bank accounts and whatnot. All right, so let's look at number 3. It says, when Amelia turned 6, her grandparents opened a college savings account for her with an initial deposit of $500. The account earns 3.2% interest compounded bi-monthly. If her grandparents make no other deposits or withdrawals, how much money will be in the account when Amelia can access it at age 18? So what does T equal here? 12, and N equals 24. Bi-monthly means twice a month. Okay, so go ahead and get that one done. Did you get a funny answer? Is that why you're laughing? A lot of punching going on. All right, Brandy, tell me what you got. Okay, y'all agree with that? Yes? Okay, good. $733.88. If you are not getting these numbers, when I give you time to work on the next one, let me know if you're doing, maybe you're doing the same wrong thing, okay? But make sure you can figure out how to type these in correctly and get the right answers, okay? That's an important part of this. All right, any questions? All right, next page. Suppose a savings account offers 0.4% interest compounded semi-annually. If Samantha opens an account with $750 and makes no other deposits or withdrawals, how much interest will she have earned after 10 years? So go ahead and get that one set up on your own and get it worked out. It's 2, not 24. All right, 80, you want to tell me what you got? 780, 58. Okay. All right, y'all agree with that? Yes, so we're good? All right, we can box it and move on. What if I told you every single one of you would be wrong then? What did you get? Okay, no, that's not the right answer either, but it's interesting that we got the same wrong answer. So do you have what you... 0.04. Oh, okay, so if you got 11, whatever it was, look at your decimal right here. This is 0.4%. That should be 0.004. So that's why you got that number.
I know why.
Why?
Because it says how much interest has she earned, so you would
Yes, this says how much interest will she have earned after 10 years. Got to read the questions, right? Do we need that 780 number? Yes, and to get there, we've done everything correct so far. We're just not finished. So $30.58 in interest earned. Read the questions. Okay. All right, we good? But if we didn't get the 780 to begin with, we understand why now, right? We're all good on that? Okay, good deal. All right, so on 5, we deposit this money and it earns 2 3/8% annual interest. So if you have a fractional percent, if this comes out to a decent decimal, meaning that it's not a repeating decimal, you still may not love it, but it's usable, then you can change it to a decimal. It's absolutely fine. What is 3/8 as a decimal? 0.375. So this is really 2.375%, right? And then you can just move your decimal and just use it as it is. If it was 3/7 and it would have be like a repeating decimal, then you'd have to have a rate that's a fraction. You want to be careful with that. But changing this one to a total decimal is fine. So go ahead and make that happen and work this out. What's t here? 35. Good. And then this would be. All right, Emmanuel, you want to tell me what you got? Oh, tell me anyway. 2,290. You agree with that? 2290.55? Yes? Yes, that's right. Very good. See, that wasn't so scary. 2290.55. Okay. Any questions about that? If you did not get that, then kind of scroll back through and look at what you typed in. Maybe you missed a number, a decimal, or something. Okay, we good? Okay, all right, good deal. All right, so let's talk about continuous compound interest. When we see this word continuous, or if it says continuously in the problem, what does that tell you is involved? E, okay. So I'm going to show you that little video that, yeah. I told you it was like 2 minutes. It's really like 1.5 minutes because there's like 30 seconds of advertisements at the end. So hang on.
We've made a video about pi, the ratio of a circle's circumference to its diameter. But there's a less famous, but equally fundamental number known to anyone who's taken high school algebra. It's about 2.718281828459045, and so on. And it was first defined by Jacob Bernoulli, but later Leonhard Euler called it E, and the name stuck. Bernoulli first defined E through compound interest. Now, compound interest says that you get a little bit of money in interest every period, and that money you gained helps you gain even more interest next period. In other words, your interest compounds. So if you stick $1 into a bank account with a 100% interest rate compounded annually, you'll get $2 at the end of a year. If it's compounded semi-annually, you'll end up with $2.25. Quarterly, and you'll end up with $2.44. Monthly, $2.61. Weekly, $2.69. See where we're going? If you increase the number of compounding periods a year towards infinity, then you'll get closer and closer to E dollars. In statistics, it describes the most important statistical distribution, the normal. In biology, it models populations of species through the logistic function. In physics, E describes the exponential decay of a radioactive material. So, while E may not be as famous as pi, it's easily as fundamental and immensely important.
So that's probably doesn't exactly explain to you exactly where it comes from, but the idea is that it comes from just the continuous compounding of anything. And E is going to show up in a lot of different things that you do. Euler didn't invent the number and say, hey, this is the number we're going to use to make all this happen, right? He discovered the relationship. And if you were in AP Stats, I would imagine that you would get to that normal distribution at some point. because I don't think you have yet, from what I've understood. I doubt in biology when you were freshmen you dealt with that formula, but if you're in AP biology, that might be something that you look at. And then in physics. So E is going to show up in a lot of different things, and it just kind of naturally works for reasons that you will probably better understand after you get a little bit more math and stuff under your belt. But just know continuous and continuously right now means we're using the E formulas. So when we talk about continuously compounding or continuously increasing like we did on Friday, this formula is actually the same as what we talked about when we did this on Friday. It's still your PERT formula. Okay, so basically we had already done continuous compound interest, but I think we were talking about trash cans and stuff. But it works the same, okay? So exact same formula. So we have suppose $800 is invested in an account at a 6% interest rate compounded continuously. So that gives it away right there. If no other withdrawals or deposits are made, find the balance in the account after 20 years. All right, so our time here is 20. We don't have an N because it's continuously compounding. So I have A equals the initial amount, which is 800, times E to the 0.06 times 20. Let's go ahead and get that typed in. All right, Ricky, tell me what you got. $2,656.09. Okay, do y'all agree with that? Yes? Okay, good. Again, make sure that you're getting these. Don't just wait for somebody else to type them in. All right, then go ahead and work on number 7. Set it all up on your own. All right, Kaylee, tell me what you got. Okay, do you all agree with that? Yes? Okay, good job. Thank you. All right, any questions at this point? Good. All right, so let's look at number 8. So before you start doing anything on number 8, let's read it. It says, Carla's investing $1,500 in a new 30-year retirement account. Determine which of the interest rates and compounding periods shown to the left would be her best investment option. So before you actually work this problem, I want you to read over what it says in option A and option B. And I want you to just make a prediction about one that would be, which one would be the best investment for her. And then just put a little star next to either option A or option B. Whatever your prediction is, nobody's going to call you out on it. I'm not even going to come look at it. It's between you and yourself, and that's it. Just, just to see what happens in the end, okay? So once you have decided which one you think might be a better investment, meaning you should get more money out of it, just make a choice. If you're not really sure how to choose, you can do eeny, meeny, miny, mo, whatever works for you, but try and make at least an educated guess. Then once you do, go ahead and figure out both of them and their amounts, and let's see where our thought processes went there. So you can go ahead and work it out after you've made a prediction. Jeremiah, what did you get for the first one?
7,810.47.
Okay, and what about the next one? Do y'all agree with this? No. I think that yours, oh, it's switched. Oh, that's okay. Oh, that's fine. Oh, what, I switched it? Or he's, oh, yeah, that's fine, that's fine. So this is the answer you're giving me. Okay, that's fine. But that doesn't go with that, does it? What did you change? You did, oh, I see what you did now. You did E for both of them, and this one is continuous, and this one is monthly. Okay, that's what it was. I was wondering how you got kind of close, but then not really. Oh, did I not? Oh, I didn't even write them down right. Yes, they should. I wrote it down wrong. You're right. I'm sorry. Should be. Bam. Sorry about that. I did it right when I did it, though, so I do have the right answers. 0.0. Sorry about that. Dang it. Why can't I just never get through the day without doing something stupid? All right. Okay. So he's fixing that. While he's fixing that, Alexis, tell me what you got for A. Okay. Do you all agree with that one? Yes. Okay. And what did you get for the second one? Okay. All right. Y'all agree with that? Yes. Okay. So as you look at these, I would imagine that some of you made the correct prediction and some of you didn't, because that's what usually happens, right? But whether you were right or wrong, did you expect them to be this different? No, that's huge, right? And this is one example of why you should have some basic understanding of this, because one day you are going to be looking at retirement plans and investment plans and things like that. And if you have a salesman that can just talk you in circles until you're confused and you don't know what's what, and you can't sit down and try and make sense of it on your own because you don't even know what it's talking about, then you may not be making the right decision. I'm not saying you have to be able to be an accountant. I mean, you'll have the formulas, you'll have a calculator, but you have to have some understanding of what's happening and what it means to be compounded whenever or whatever, and how to figure that out to see what would be the best, the best choice for you. So to answer the question then, it says blah, blah, blah. So we would say option A. Would we agree with that? Option A would be her best investment. All right, we're all good with that? Any questions at all? All right, so just make sure that you are reading the questions and answering what's actually being asked of you and trying to make sense of what's going on with these, all right? We good? All right, go ahead and get them glued in, taped in, whatever you're going to do.